This is the second part of the video for 7.4, and normally we don't do too much in Ready for More, except for this one is definitely necessary because of what we go over. So it says, when defining the trig ratios using right triangles, we name possible ratios of sides, such as sine, defined as the length of the opposite over the hypotenuse, and the cosine is adjacent over hypotenuse, and the tangent, which is opposite over adjacent. It's sometimes useful to consider the reciprocals of these ratios, leading to definitions of three additional reciprocal trig ratios: secant, cosecant, and cotangent. So these are just three of them. And just so that you know, the way I memorize is secant is hypotenuse. Oops, sorry, is hypotenuse over adjacent, which is like the cosine, right? Hypotenuse over adjacent. Normally it's adjacent over hypotenuse, right? That's cosine. So these two are buddies, except for their reciprocals of each other. So here's my little reminder that cosine of an angle is adjacent over hypotenuse. And the way I remember them is because, like, see how this C and this S are here, and then this is the S and this is a C. This helps me remember, so I'm just giving you my little tips. Same thing goes with cosecant. This is hypotenuse over opposite. This reminds me of sine, which is opposite over hypotenuse, right? And then last but not least, which is cotangent, which is adjacent over opposite, which reminds me of tangent, and tangent is opposite over adjacent. So if you already know your sine, cosine, and tangent, secant, cosecant, cotangent are like their reciprocals. So complete the following like kind of statements. And then I just want to make sure that you guys are comfortable with this. We're not going to be going over everything. We won't be going over the graphs of them because we'll be depending on tangent, but I will show you just so that it makes sense to you. So the what ratio is the reciprocal of sine? So the which one, who is the reciprocal of sine? So sine is opposite over hypotenuse. Oh, that's cosecant. So I'm going to write CSC. Okay. CSE is short for cosecant. Okay. The blank ratio is the reciprocal of cosine. That's secant. Short is SEC. And last but not least, the cotangent is COT for short. Cotangent is the reciprocal of tangent. Okay, so here I will write 1 over cosine is secant of theta. This is cosecant theta, and this is cotangent theta. So I just need you to remember that these two are related. And then going the other way from cotangent, we go, this is tangent theta. This is cosine theta. Again, because I look at this S and this C, this S, and then this is sine theta. Okay. So I would definitely make sure that these, this like little part right here is memorized, because this will help you do a couple more things in the next couple of lessons. It says there are also line segments that can be defined on the unit circle. So this part here, I am going to skip because they're going to kind of lead you into the sketch of the graphs. And I kind of want you to lean on Desmos for this because I want you to understand where they all come from. So the first thing I'm going to do is I'm going to graph the sine of x. And along with that, I'm going to graph his reciprocal, which is cosecant. So I'm going to graph cosecant of x. And if, like, I just want you to notice a couple of things, right? Number one, they're together, right? They're together at the maximums and the minimums. And then it makes sense. Now, listen, because cosecant, the green function, is the reciprocal of sine. When sine is 0, then you have an asymptote at that point for cosecant. So I'm going to say that again. This graph, the green graph, makes sense to me. Cosecant's graph makes sense to me because as sine is equal to 0, you have an asymptote for your cosecant. And as you approach and you get smaller and smaller and closer to 0, you're dividing by a bigger and bigger and bigger and bigger number, which makes your numbers either get really, really small or get really, really large, depending on if you're on the negative side or the positive side. So this is kind of all I wanted to show you with this. So I just want to show you similarly with cosine of x as well as secant of x. And you'll see it's the same kind of like movement, right? When they're together at the maximums and the minimums of cosine. And then you have, when cosine is 0, you have these asymptotes, okay? Which, again, it makes sense. So what else did I want to show you? Okay, that was the biggest thing that I wanted to show you was this part here, the graphs, as well as the definitions of your reciprocals. So make sure that you're comfortable with that. Have a great day. Thanks for listening.